I don't have the mic, but never mind. This man needs no introduction, but because he has run the vast majority of the work for FOSDEM, for the Open Media Room, in conjunction with Adi and Fran and myself, I'd welcome you around the applause.
Thank you.
So it's Christophe Massiot, and he'll be talking about Upipe, a very interesting project that we work on as well.
So thank you, Kiran. Maybe I should have changed my T-shirt because I'm not the dev room person now, but I'm the company person now. But they told me not to do that in front of the camera, so it was too dangerous. So a new talk about Upipe. We already did one last year and the year before, but it will be on a different topic this time. The first question for people who weren't there the previous year is, what is Upipe? So Upipe is a young multimedia framework written in C. We started in 2012, so that means we're quite young. Well, not as young now, but still quite young compared to similar projects who were born in the 1990s. That means we have, of course, a lot fewer modules, fewer support, but also we have been able to make some educated choice about the technologies of today. So Upipe was initiated by my company, OpenHeadend, and so some of my employees. But there are now 3 supporting companies, including Kiran's as well, who uses it. And last time I counted 7 contributors. The focus of Upipe is a bit different from what you can see with VLC or maybe GStreamer. We focus on reliability and efficiency and above all compliance. So that means we don't aim at playing any kind of file that's on the internet. If it doesn't comply to the standard it's supposed to comply to, we will say meh. We also focus on broadcast and professional applications. Actually, most of the use cases I have today are on the real world, in the real broadcast world, with real customers in the broadcast domain. The license of Upipe is MIT and GPL, so it's not both. Some modules are MIT, the core is MIT, the headers are MIT. The main pipes are MIT, that is what you need to build a pipeline, basically. Duplication stuff, sources, file source, file sync, UDP, and so on. All of that is MIT. We have some modules that are LGPL. That's mainly the code that deals with the codec format. So what we call the framers in our lingo. And also some support libraries are also LGPL, like libAV codec. So the code, the binding code is also LGPL. So those of you who were there the previous years, what's new? The question is simple. So too long, don't read. We've had a lot of work on the event loop API to make it more complete. So now you don't need to call anymore the event loop directly from your program, and it also is launching pthread workers. We have a nice utility to dump pipeline in GraphViz format. So some of the slides you will see later have been automatically generated from Upipe using GraphViz. You'll see that's quite nice, quite verbose as well. But the dual-JIT bindings, I talked about them last year, but it's finally it's finally been merged in. So you can now write a Upipe client using just Lua. And Lua is interesting for that because it abstracts all the ref counting of the structures. Most of our structures are ref counted, but in Lua takes care of the ref counts and frees automatically the structure you don't use anymore. In C, you have to do it by hand. So that's interesting. In the feature side, we've had people contributing, a third company contributing an HLS client. So some other frameworks have also HLS clients, but we now do have one where you could choose the bandwidth or the variant you want to have, and you can remultiplex it, repurpose it in a different format. I will show later an example where we repurpose HLS to a transport stream, a UDP transport stream, standard transport stream. We've had some work on H265 as well, so we're able to decode it and support it. Veng support in the SDI. If you don't know what that means, don't care. If you do, bad for you. Well, I wanted to release pre-release number 5, but the work is not finished yet, but we'll probably do that in the next few weeks. And after that, 1.0, we hope. So unlike previous year, I'm not here to give you an extensive talk on the insides of Upipe and why it's a good pipeline, but I will give you examples of what you can do with Upipe. And I will start with an inventory of all the modules we have for inputs, outputs, filters, and so on. And then I talk about use cases, typical use cases that are in production today. So the inputs we have, well, some of them are quite standard. Of course, in the broadcast world, we still have specific connections like SDI and ASI, so we support 2 vendors for that. Natively inside Upipe, we support, of course, DeFi, UDP, HTTP, and so on protocols. We have a compliant ESD mux. Compliant is important for us, as I said. We also have an RTP demux to be able to read one or several RTP streams from the same program. HLS client, I talked about it already. I have here multicast directory. It's a bit of a specific format that allows you to record 24/7 a stream in chunks and expire older chunks. So we can also support that with Upipe. It comes from a program that's called multicast as part of the VDRAN project. Externally, we support libv format for sources. It's actually a work in progress. Some of the formats may not work at the moment because there are still adaptations to do. As for the outputs, well, again, we have hardware outputs from SDI and ASI that have not been merged at the moment, but they exist somewhere on GitHub. So if you look for it, you can ask us and we'll tell you where it is. Natively, we support, as usual, the PHY, UDP, RTP. We also support compliant ESMux. So that's one of a kind. That's probably the things that differentiate us most from other projects, in that we have a compliant TSMux, that output stream that are analyzed by a professional analyzer, and they say it's okay. So that's quite a good thing. Multicast directory again. And we can use also external libraries. So libv format, this time it works. So in production, I have streams to RTMP, Icecast, and other formats using libv format. And GLX, ALSA. And we were talking yesterday about a Wayland. Funman was talking about a Wayland output also that he's working on. So inputs and outputs are okay, but what can you do in between? So first, the filters that we have. So internally, natively, we support, well, the standard deinterlace bleating. Bleating means to take a picture and you bleat it on top of your video, like a logo, with or without transparency. Bleating also allows us to do mosaic. I will show you later. Crop. We also have V210 pack and pack assembly optimized functions. If you don't know what it is, good for you. It's some kind of a format output by some SDI card for 10-bit video. And so it's more compact than the traditional approach on 16-bit, but it's also much harder to read. External libraries, of course, are very useful for filters. Of course, libv codec provides most of our decoders and encoders. X264 is also an encoder we use a lot. And the traditional software resample as well. libspeaks is a recent addition that allows to do resampling without changing the pitch. So it's actually much nicer in the broadcast world where you have to compensate for a drift, while you don't hear it. Thanks to libspeaks. And well, we also have bindings to libzvbi, but just for American subtitling system. Another important piece of our project is what we call the framers. So the framers are analog to what EV codec calls the parsers. So that's basically a place where you have the knowledge about the codecs. So that's pieces of code that will parse the codecs, tell you this is a frame, this is a header for a frame, this is a 25 FPS stream, and interpolates the PTS from frame to frame, and so on. But in addition to that, so it's not just a parser, but it also acts as what EV codec again calls bitstream filter that allows you to transform a stream format into another. For instance, in H.264, if you want to put H.264 into TS, you have an annex called Annex B. That is, you put a start code in front of your structures. If you want to put H.264 in MP4, it's a different format. It's not start code anymore, but it's based on size. And so this transformation is dealt with by the framers in our project. We also have an interesting mechanism in which all of this is actually performed automatically without even you knowing it. So basically the thing talks to the previous pipes and say, I need Annex B. And so the framer will say, oh, I don't receive Annex B, so I will convert automatically. And we have support for, well, a few video formats, MPEG-2, H.264, and now H.265. That's a recent addition. A lot of audio formats and subtitling systems, so teletext and subtitles and DVB subtitles. Why would you use Upipe for broadcast world? Well, we have several assets, in addition to those I already mentioned. Our clock system is actually one of the major points, as we said yesterday at the meetup. In Upipe, we keep actually 3 clocks for each packet. The original timestamp that was in the stream, a reconstructed timestamp that's always monotonously increasing. So the demux makes sure that it's always monotonously increasing, and that's what we could call the program timestamp. So it's basically the clock of the encoder, the guy that gives you the stream. And we have the system timestamp. So the system timestamp is based on the clock of your hardware, your machine. And so typically for display, you would use the system timestamp. Most of the projects only keep the system timestamp, but that means that if you have a drift, sometimes you have a shorter delay or longer delay, and so you don't only have 40 milliseconds exactly between frames, and that's a problem for some codecs. So that's why we keep all of those clocks. Also, the system timestamp, I said it was the system time. That's not completely true. Usually it's get time of day or clock get time. But there are also use cases where it's interesting to get the clock of a hardware clock, like on the ASI or SDI card. And that's a use case we have in reality. So we can replace all of these by any other hardware clock if you want. In Upipe, everything is dynamic. That means the model of Upipe is transpose stream. So in transpose stream, you can have new elementary stream. You can remove an elementary stream at any time. So you can have subtitling arriving all of a sudden. So everything has been built in Upipe to allow for automatic forking of a new decoder, a new parser, and so on, if needed. If the interface, if the user wants it, of course. But so the framework allows that. We also have efficient threading. You decide where you put the threads, not our framework. So if you have a thread, let's say AV codec, usually you want to deploy to another thread, you just create what we call worker, and it will move to another thread. If you don't want it, for some reason, because for instance, you have very low latency, you can work with no thread at all. The framework allows that, as long as your core is enough, of course, to do all of that. We also have shared buffers with copy on write and zero copy semantics. So now you can see that more and more, but we've had that since 2012. And the UA bindings I already talked about earlier. So that was for the assets and the inventory. Let's see a few real-world examples. So the first example, I'm not sure you will see properly, but let's try. The first real-world example I have is some kind of a player. So it can be a player on your PC, but it can also be an IRD, an integrated receiver decoder, like in the professional world. So these graphs have been made by the Upipe dump API that I talked about earlier. So it's actually everything that is spawned when you start a Upipe pipeline. So on top of it, you have the source. Actually, it's in a worker, the W worker source. So it's in a different thread for performance reasons. And we read from, well, in that case, from a file. It can be also a FIFO. Then is coming the TS demux. So TMUX demux is the main thread here. Is the main pipe, super pipe we call it, that has a son. That's the program. And two other sons. The program has two other sons, that's the audio and that's the video. So inside the demux itself, there are a lot of subpipes that do a lot of things like decaps, PS decaps, framers, and so on. And on the output, you have your frames. And in two different workers for audio and video, you decode it with AV codec. Here is the part of the pipeline that deals with subtitles, bleeding subtitles, if you have some. In our case, we don't have. FFmpeg is something that uses software scale and deinterlace to deinterlace and, well, put it in the correct format. It's RGB in that case because we are using GLX. And TrickP and play video and play pipe are used for synchronization. So it looks and the audio is also on its own thread, so that's why it's a worker. I'm not sure if you can see it properly. I don't see it in that distance, but I hope so. Let's take a little bit more complicated example, that a program that does a TS remultiplexing. So we have a TS at the source. So again, in our worker source here, we have a UDP source this time, RTP decaps. And we want to create another UDP, and we remultiplex in between. We could also transcode, but that would add more complexity to the graph. So the graph is already barely readable, so let's try to keep it simpler. So again, after the source, we enter the TS demux. So again, in that case, I only have one elementary stream, so I chose to have only one video because otherwise it complicates things a lot. So the internal of the TS demux is the split pipe that allows to select which PID you want. And we also have decoders for PAT and PMT, which has internal structures of the TS. And then you have the TS mux, which is quite symmetric compared to the TS demux. Mux program and well, input elementary stream. The output of the TS mux is then sent to also another worker thread that adds an RTP header and outputs it to UDP. The last use case, because I'm running out of time, is a quite nice application we use in my company for recording. So actually I simplified it a lot because otherwise it would be too big to display on the screen. But basically we have an application where we receive a stream from UDP again, UDP RTP. We record it immediately as a TS, but at the same time we decode it, so demux it, decode it, to get some frames, the key frames for thumbnails. And we recreate JPEGs from the thumbnails. So here you see a dub pipe that one is directly written to the disk, and the other is sent to the TS demux again. So now you're used to it. And at the output of the TS demux, we have a bit more pipeline. Between the arrows, you can see the types, but it's a bit... so AV codec, the interlace, because for JPEG you wanted an interlace. And this pipeline here is ad hoc, creates sums out of the frames we've selected. And we record it with AV codec encoder, this one, for JPEG, and write it with a file sync to a file. Okay, last use case, but this time I won't show you a graph because it would be enormous. It's a mosaic. So this is, for instance, a mosaic we have at work. So this is a real-life example. So basically all of this is done with Upipe, using a pipeline per input, outputting two bleed functions, so bleed pipes, that will bleed each of the thumb to a single picture. And so normally it's also live. This is also for the audio, so that's a nice contribution by OBS. It moves with your audio level. So all of this is done with a Upipe pipeline. Other use cases that we have in production that I did not have time to talk about here. So IRD, of course, we have a company using that from TS. We could also imagine it from HLS. Live encoder, live transcoder to TS or to RTMP, IceCast, anything that AV format support, basically. File transcoder, that's something we have in our company as well. We from TS usually to MP4. That's a typical use case for us. We also have an MPTS mux. That's a product from my company as well, entirely based on Upipe and the TS mux that you've seen earlier. it would be quite a large workflow to show, but it works with Upipe. And also something we demonstrated actually at the IBC last year is a cloud system with overlay. So we've just played out files, decoded files, and added a logo that moves, and a banner, and a picture inside of a picture in picture, and so on. So I think I'm right on time for some question, Kieran.
Any questions? Manuel?
Yes. I just wanted you mentioned HTTP. Is it compatible with HTTPS?
So you said I talked about HTTP, but is it compatible with HTTPS? At the moment, I don't think so, because the company that provided it doesn't use it. So.
All right, the third party work with you.
Yes, it's a nameless network operator. I'm not sure we can say who it is, who contributed that part to us. And they did HTTP, they did AES, also unscrambling for if the stream is scrambled.
AES encryption is available?
Yes, it's already merged in. It also supports whether you have the audio inside, mixed with the video, or a separate file variant. I don't know how you call it in your M3 or U8.
You said that your MPTS marks are standards compliant. Which of the many MPTS standards?
So which MPTS standard do we comply to? First, the ISO. And what I was actually referring to with that is the fact that we're TSTD compliant. That means that the timing of our packets has very strong constraints in the TS specification. You can't send the packet too early, you can't send it too late either, you can't burst, and so on. All of that is specified in the specification. And it's actually very difficult to understand. It took me years. So that was what I was referring to. We also comply to DVB, and we have decoders for SDT and NIT and so on. Well, usual. That's not specific to our project, but yeah.
The use cases, do you have the code for those samples online, or is it?
The use cases for?
Yeah, have you published the code for the use cases that you showed?
So have we published the code for the use cases? Some of them are online. So the player basically is an example that we call Uplay. That's in the example directory of the Upipe repository. So if you want to see our code, it's on GitHub. So the player is the transcoder. No, the TS3 mux is also. You have it's a test unit actually called Upipe TS test that we use to test that our demux and mux don't change behavior from release to release. The third one was the recording. Is not. It's actually not published yet. Probably at some point we will, but not so far. One also very important thing, if you wish to contact us, we have a website, upipe.org, of course. We have our GitHub. And if you wish to talk to us, the best is to come to our IRC, Upipe on Freenode. We also have a mailing list, but usually when I say that, Kieran laughs.
Sorry for asking. So, what are you supporting for bank in Upipe? So, do you support teletext being in the bank, like 47 or 2031?
So what kind of subtitles standard we support in Upipe? That's okay. That's
For bank.
For Vank, sorry. So for video and series, for those of you who don't know that, video and series is a part of the picture on the SDI interface, so raw video that embeds some structure. So basically OP47, so that means teletext, basically. So we take that and we turn it into a teletext packet. And other things that we do.
All the Americans, so in SD, CEA 608, legacy teletext, in HD 708, and some other things. All the American SD and all the European SD, and the pass-through of the US bank as well. So captions and subtitles.
Yeah, I'm not sure it's in Vank, it's in VBI, right?
Well, in SD it's VBI.
Yeah, in SD it's VBI.
Yeah.
I was specifically referring to Vank because I worked on it last summer. And the other thing we support is COTI 104. That's not for subtitling, but that's to determine the timing of the beginning of show or the end of the show, or splicing and so on.
One more question.
Really quick, how about DVB sub?
So how about DVB sub? The thing is, DVB sub, you won't find it in SDI, because there is no, as far as I know, there is no standard to embed it in SDI. From OTS to OTS, we of course demultiplex it and remultiplex it. I think you have code that allows to put it on screen. DVB sub.
That's actually for teletext, but it
not just for teletext.
It should work for the bitmap should work. We don't do subtitles.
Actually, it's never been tested, but it should work. If your question was, do we support transcoding teletext to DVB sub? At the moment, no. But this is something we're seriously thinking about.
Okay, thank you.
That's it, I think. Thank you.
You're welcome.